Section 1.3 is relatively short, and what we're going to do is review what we mean by the terms physical and chemical properties. So if you recall, we said that chemistry was the scientific study of matter, its properties, and transformations. So we've slowly been working through this definition, and here we are talking about properties. So properties are things that allow you to distinguish one object from another. So for example, when I go out to the parking lot and I'm trying to find my car, I know that my car is green. It's a hatchback. It's a Mazda. And that would allow me to distinguish my car from every other car in the parking lot, right? So if I forgot where I parked it, I would be able to find my car on the basis of its properties. So often we'll define properties of matter as being of two types, either chemical properties or physical properties. And these terms are related to how we defined physical and chemical previously. So physical properties are those that you can observe without either changing or attempting to change the composition of the sample. And by that we mean we're not going to break or make connections between atoms, what we call chemical bonds. No chemical bonds are going to be made or broken in order to determine an object's physical properties. Now, chemical properties describe what happens when attempts are made to change matter into other kinds of matter. So when we do attempt to make/break chemical bonds. So a classic example of determining a chemical property would be to see whether you could burn it, right? So if it was gasoline, we know that gasoline would burn well if we try to set fire to it. If it's water, we know that water doesn't burn particularly well, so we could distinguish water from gasoline on the basis of that chemical property. So when you determine a chemical property, you could have the result of changing the composition of your sample. You could lose your entire sample. Now, another way that we can divide properties is we can consider properties to be either extensive or intensive. And extensive properties depend on the amount of the substance. So a classic example would be mass. For a solid or for a liquid, the volume is also going to be an extensive property. If we have more of a liquid, its volume will increase. So the property changes with the amount of substance. Intensive properties are properties that are independent of the amount of substance. So a good example of that is the temperature. If I have a bathtub full of water and it's at, say, a nice comfortable 80 degrees Fahrenheit, if I take a spoonful of that water, that's a pretty big spoon, then the water that would be in that spoon would also be at 80 degrees Fahrenheit. So it doesn't really depend, or it doesn't at all depend on the amount of the substance. Other examples of intensive property would be things like density. Water has a density of 1 gram per 1 milliliter, and it doesn't matter the size of the sample, it will always have that density. So we said that chemistry is the study of matter, its properties, and its transformation. Another way of saying transformation is to say change. And we can also define changes as being, or describe changes as being, either physical or chemical. So physical changes are those that don't result in a change in a change in composition of our sample. So these are, there's a few sort of typical examples of this. One is subdivision, dividing something into smaller pieces. Another is dissolution, which is where we just dissolve something in a solvent. All we're doing here is dispersing our sample throughout that solvent. We're not actually making or breaking any chemical bonds there. When we bend or stretch or compress something, when we change its shape, we're only performing a physical change, we're not performing a chemical change. And then the other very, very common physical change is some kind of change of state. So we could boil something or evaporate it. We could melt something. Sometimes this is called fusion. We'll come back to that later. Or we could sublime something. But any change of state is always a physical process. Chemical changes are those changes that do result in a change in the composition of our sample. That is, that we are going to make or break, perhaps both of those things, some chemical bonds. And good examples of chemical changes would be burning something, what we call combustion. When chemical bonds in a substance break, we call this process decomposition. So we have one substance that falls apart and forms two or more new substances. Another example of a chemical change would be combination, where multiple substances combine to form spelling's a bit wacky there, combine to form a single substance. Or we can have what we call displacement, where multiple substances come together and they swap some parts. So the key thing is that chemical changes always involve the making and or breaking of chemical bonds. That's the key property that all chemical changes have. Okay, so like I said, relatively short section for a 1.3. Hope you found the video helpful.